So if we go ahead and take the derivative of s of t to find out what v of t is, we come up with 2t minus 4. And if we take the derivative of the velocity function, we can find the acceleration function, and that's just going to give us a constant value of 2. Now what we're going to be very what we're going to be very concerned about is whether or not s of t, v of t, and a of t is either equal to 0, greater than 0, or less than 0. Or in other words, it is going to be equal to 0, positive, or negative. And that will help us analyze how the particle is moving in a straight line. Okay, let's go ahead and take a look at what this means then. Now, if s of t is equal to 0, that means, of course, that the particle is at the origin. Okay, so notice that when s of t is equal to 0, where is s of t equal to 0? Here it is, s of t is equal to 0. That's when time is equal to 1, and that's when time is equal to 3. That's when the particle is at the origin. So notice that that's the same location here in the two-dimensional graph. We said also that if s of t is greater than 0 or positive, then that means that it's to the right of the origin. So notice that when s of t is greater than 0, all of these values over here, so in other words, between 0 and 1 second, and after 3 seconds, so between 0 and 1 second and after 3 seconds, the particle is to the right of the origin. Okay, when s of t is negative or less than 0, that means that it's to the left of the origin, and the only time that it's to the left of the origin is between when time is 1, 2, and 3. So 1, 2, and 3. And so there you go. Okay, so let's go up one step further, and let's take a look at the values of the velocity function. Now, when the velocity is at 0, that means that the particle is at rest, at an instant. Okay? So let's just take a look at what's happening here. Where, in fact, is the particle actually at rest? Now, we want to set the function v of t to be equal to 0. If we do that, then we know that 2t minus 4 is equal to 0. That means that when t is equal to 2, the particle is actually at rest. It pauses just for an instant. So if we come and start here, notice that we come this way, it pauses and then it changes direction. So what happens then is that at this particular value here, when t is equal to 2, we know that the particle is actually at a moment, an instant of rest. Okay, and notice where it is in the two-dimensional graph. Now, if we go ahead and talk about when the velocity is actually greater than 0, that means that it's moving to the right, then that means that from here on, the particle actually has a positive velocity. Okay, so anytime after 2, velocity is positive. Okay, let's go ahead and take a look at when the velocity is actually less than 0 or negative. That means that the particle is actually moving to the left, and that's anywhere from t is equal to 0 to t is equal to 2. Now let's come back here, and I've actually gone ahead and tried to also show us where the positive and the negatives and the zeros actually occur for each one of the functions s of t, v of t, and a of t. Now I think everybody's pretty clear as to what's happening with s of t. Let's focus on v of t. Now remember that when we talked about v of t was actually the first derivative of s of t, which meant that we're talking about the instantaneous rate of change of s of t at any particular value on the function. Okay, so let's take a look. What is the value of the slope of the tangent lines anywhere between t is equal to 0 and 2? So what we notice is that all of these slopes of the tangent lines are all negative. Okay, so notice that for v of t, to this point, according to this point here, everything to the left of that, the value of v of t is actually negative. Now what we said is that here, now that we know that this is a horizontal tangency, that we know the slope is actually equal to 0. So I'm going to just put a dot there. And notice that after that, when we go this way, notice that the slopes of all the tangency lines are all positive. So notice that we have here positives. So let's take a look. What happens to the particle? Well, it's actually when t is equal to 0 to t is equal to 2, the particle is moving to the left. And notice, that's exactly what's happening. And then when t is equal to 2, it is actually going to pause for a moment. And right there. And then after that, after t is equal to 2, the velocity is going to be positive. That means that the particle is moving to the right. So notice the particle is now moving to the right. So there's consistency with what we have here, and this information that's given in the two-dimensional graph can be very easily transferred to a sign graph. And based upon the signs of the velocity, I can tell whether the particle is at rest, moving to the right, or moving to the left. Okay, the last one that we're going to take a look at is acceleration. Now, we haven't really dealt much with the second derivative, so we're just going to introduce it at this point. Now, what I'm going to say is that when your acceleration is equal to 0, this means that the velocity is at its maximum or at its minimum. We're also going to say that when the acceleration is greater than 0, which is the case in this case, that the velocity of the particle is actually increasing. And when we go ahead and take a look at this here, the acceleration, if a of t is actually less than 0, that means that p's velocity is actually decreasing. Now, let's just go ahead and take a look at what's happening here, because in this situation, we know that the acceleration is 2, which is greater than 0. That means that the velocity is actually increasing for this entire part. So notice that here, the acceleration is actually increasing for all values of t that we have. So how does that actually work? Now, if we go ahead and you have to remember that the acceleration is also a vector quantity. So we're talking about a direction as well as a magnitude. So notice that in this case, the velocity is actually negative, right? The velocity is actually negative, but notice that the velocity is actually slowing down, which means then that the acceleration is positive. So that means that with a negative velocity and a positive acceleration, the particle actually slows down. And then notice that it comes at rest here. And then after that, what's going to happen is that that positive acceleration is actually going to start moving the graph or moving the particle to the right and forcing the velocity to actually become positive. So what happens here is, even though the velocity is negative here and positive here, being that there's always going to be a positive acceleration of a value of 2, then notice that the negative velocity is actually going to decrease. In other words, it's going to get smaller and smaller. It's going to get to this point over here where the particle is at rest and the velocity is equal to 0. And then after that, it's going to push the particle faster and faster to the right, because the acceleration is positive, meaning that it's making the velocity increase in a positive direction. Okay? So that's how everything is working together. If you can actually go ahead and see the relationship between the two-dimensional graph, the sign chart, as well as the motion graph, by applying this table here, then you've understood everything that you need to know with regards to motion in a straight line. Okay, one other thing that I would like to go ahead and ask you to think about, and we can discuss, of course, in class, is based upon the sign values of v of t and a of t. Okay, we're only talking about these two right here. When is speed increasing? When is speed decreasing? Okay, now remember, the difference between velocity and speed is velocity has a direction and a magnitude. It is a vector quantity. But when we talk about speed, we're only talking about a scalar quantity. Okay, so take a look at the example here. Think about, when is the speed actually increasing? What has to happen in order for speed to increase? And also you can think about what needs to happen in order for the speed to decrease as well. And we'll go ahead and talk about this the next time that we meet in class. Okay, so give it a shot. Motion in a straight line, part 2. Good luck, and see you next time. Bye-bye.